Hey everyone, how are we doing? Hopefully everyone had a very nice Christmas break. We're going to go ahead and get started with today's lesson. So at the top of your paper, go ahead and write lesson 3-4.
I'm going to pull the car up so you don't have to walk so far.
And this is write algebraic expressions. All right, so everyone should have that written on there right now. If you remember lesson 3-3, that was numerical expressions. Well, algebraic expressions is going to be something similar. We're going to be throwing in a little bit of algebra. So some of you, this will be your first attempt at some algebra. Again, just keep an open mind while we're doing this, and I think you'll do just fine. So to start things off, we have a few definitions we have to cover. So we'll skip down a line, we'll put a bullet, and we're going to write down the word, which is variable. And a variable is a letter or symbol that represents an unknown quantity. So you've seen this in science, I'm sure, in math. I want to say this has been touched on a little bit, especially in younger grades where you have sometimes they refer to them as magic boxes. You put a number in and another number comes out. So an example of this could look like this, right? Example, be 4 times n. And in this case, n would be the variable. So again, whether it's n or it's a or it's r, q, it could be usually anything. A lot of times you'll see math books, they'll get stuck on using certain letters to represent other quantities. But the variable is just the unknown value here. So 4 times something, and we're just not sure what n is yet. All right, the next vocab word that we're going to have here, we're going to skip down a line. I'm going to write algebraic expression. And an algebraic expression is a type of math expression that has at least one variable and at least one operation. So remember, an operation would be adding, subtracting, multiplying, dividing. So again, an example of this is 4 times n, again, but the entire thing would be the algebraic expression, 4 times n. So this would be at least one variable, and this would be at least one operation. But again, there could be more than one variable. There could be more than one operation. All right, so now we need to get into describe and actually identify some parts of an expression. So let's get down here, we'll put a bullet, and we'll label it parts of an expression. So we'll have some more vocab words in here. But again, this is going to be, like I said, actual parts of the expression that we need to know about. So the first part, skip down, put a bullet, would be called term. And to describe a term, it is each part of an expression that is separated by a plus or minus sign. So each part of an expression that is separated by a plus or minus sign. I'm going to go ahead and underline these so you pay extra close attention to those two words. A plus sign or minus sign has to be separated by those for it to be considered a term. And after we write down a couple of these parts of the expression, we'll go through with an example to be able to identify those. All right, the next word that we're going to do is, we'll get down, put a bullet, it is coefficient. And a coefficient is the number that is multiplied by a variable. So coefficient, the number that is multiplied by a variable. So again, like I said, we'll get into an example of this. I just want to make sure we get these terms down. And the last one that we're going to cover here. So again, we'll skip down, put a bullet. It's called a constant numerical value. Constant numerical value. And this is the standalone whole number in the equation. So constant numerical value, and this is the standalone whole number in the equation. So these are the parts of the expression, the term, the coefficient, and the constant numerical value. So underneath this, I'm going to put an example of an algebraic expression, and we're going to go ahead and identify those parts. So get down, we'll put example. And an example is going to be 12r plus r over 2 minus 19. So looking at this, you might be a little confused by it. It looks a little confusing. Again, if you've never done this, it could look confusing. But if we're going to break it down into some of the parts that we need to identify in this expression. So first off, we have the term, which again is each part of the expression that is separated by a plus or minus sign. So if I'm looking through here, I can see Here's a plus sign, here's a minus sign. So it's each one of these sections that's separated by these operations here. So here's one, here's one, and here's one. Because again, they're separated by these operations. So how many are there? There's 1, 2, and 3. So there's 3 terms. There's 3 terms in this algebraic expression. 1, 2, and 3. Again, they're separated by the plus and or the minus sign. All right, next we want to look at the coefficient. Coefficients, the numbers multiplied by a variable. So looking at this, I see 2 variables. I see this r and this r. So really they're the same variable, but they're 2 different locations in here. But which one is being multiplied here? Well, it's not this one, because this one I know when I see a fraction, this fraction line really means divide, so that's not multiplication. This is going to be the one that is being multiplied. This is really saying 12 times r. Remember, if I have a variable or a letter, I can write it right next to the number and it means multiply. I could put it in parentheses and that would also mean multiply. Or I could put a multiplication sign in between there and it would mean the same thing. So the coefficient would be this number right here. So the number that is multiplied by the variable. So this is the coefficient. And the last part is we're looking for what is the constant numerical value, which number in here has a constant numerical value. So the number in here that has the constant numerical value means it's not multiplied by anything, it's not being divided by anything, this is just the standalone whole number in the equation. In this case, 19 is our constant numerical value. So a better way to explain this was, it's not actually named this, this just happens to be the number in here that has the constant numerical value, which would be this 19. So again, I can look at this and I can tell that there are 3 terms here because they're separated. I can tell that 12 is the coefficient because it's the one being multiplied by a variable. And then I can tell that 19 is the digit in here that has the constant numerical value. All right, we're going to go ahead and turn our page. We have some more notes we're going to cover. All right, so in this part of the notes, we are going to be creating a little chart or a little graph that's going to help us be able to actually write some of these these algebraic expressions. Just like word problems, a lot of times when you look at word problems, there's certain words that indicate if you're supposed to add or subtract or multiply or divide. Well, it's the same thing rings true with algebraic expressions. So let's go ahead and start by writing this down. We're going to make a box from red line to red line here, and it's going to be 5 lines long, or I should say tall. So we'll start at the top and go down 1, 2, 3, 4, 5. And I'm going to take that all the way over across the page to this red line. Do the same thing, follow this line here, all the way across, and connect it. Then, each one of these blue lines, I'm going to draw a line on, just to kind of make it a little bit more defined. Nice. So once you're done with that part, you might want to see what words I'm going to be writing here first, but I'm going to be splitting this up into 4 boxes. Remember, you can push pause anytime you need to get caught up if I'm going a little too fast. So in this section up here, I'm going to write word phrase. And then I'm going to draw a line maybe around here. And then here we're going to write the word variable. And I'll close that in. And then next I'm going to write operation. And again, I'll close this one in. And lastly, hopefully I can write small enough here. We're going to write algebraic expression. And I might just write ext just to kind of be able to fit in there. All right, so underneath word phrase, these are going to be possible scenarios or possible ways that it would be worded inside possible ways it would be worded if you were asked to write in an algebraic expression. So this first way could say the sum of 8 and a number A. I'm going to put those in kind of quotations just so it highlights that A. So the sum of 8 and a number A. So first of all, what is the variable going to be here? Well, the only letter that's in here that's used to represent something else would be A. So that will be our variable. Our operation, when I read through here, there should be one word that sticks out to that it represents an operation, and that is sum. And sum would mean addition. Or I'll just write add. So then if I had to actually write the algebraic expression, so the sum of 8 and a number A. So I know I'm going to be adding 8 plus A. And again, I'm putting these on here. You wouldn't necessarily do that, but I just want to make sure you don't think that's a 9 or kind of get you confused with that being another number instead of a letter. But 8 plus A. All right. Another way this could be written would be a word phrase that look like this. Be 5 less than a number B. And this one, I think B looks enough like a B. I'm not going to put any quotations around it. So the variable, again, 5 less than a number B. So it would be B would be our variable. For the operation, I'm looking through here. Is there any word or words that signify what operation would be? And if I look at this, less than, and we know that means to subtract. So now we have to think, all right, how would I write this as an algebraic expression? 5 less than a number B. So I'm thinking not 5 minus B, but I'm thinking 5 less than a number B. So that would be B minus 5. Again, it's one of those things you have to make sure you put this in the right order because B minus 5 is going to be different than 5 minus B. Just like 5 minus 4 is different than 4 minus 5. So make sure we're putting these in the correct order. All right, the next way this could look would be the product of 8 and a number C. the product of 8 and a number C. So I want to think about what the variable would be in this case. In this case, the variable would be C. Now, what operation is it asking me to do here? The product of 8 and a number C. So we know product means to multiply. So this would be multiply. And the algebraic expression in this case, the product, so 8 times something, and a number C. So it'd be 8 times C, or just 8C. Now, could you write it 8, then a multiplication sign in C? Yes. But again, with you guys being 6th grade now, you're going to see a lot of it mostly looking like this, whenever you're multiplying a number times a variable, or a coefficient times a variable. All right, we're going to do one more here. And in this case, could be the quotient of a number D, we have to go underneath here because I'm out of space, divided by 2. So the quotient of a number D divided by 2. So in this, I know that my variable is going to be D. And the operation, is there a certain word in here that will tell me what operation is going to be used here? That's quotient. And quotient means to divide. So this is going to be probably the most confusing type for you, just because to be able to write this the way that they're going to want it. So it's the quotient, answer to division problem, of a number D divided by 2. So this is going to be, you could write it 2 different ways here. D divided by 2, or the way you'll see it most of the time would be, and actually I'm going to write it underneath here so I have more room. It's going to be D over 2. Because if we remember, when you have a fraction like this, this line right here just means to divide. And I've taught you before, you do a little quarter turn if you turn this into a division problem. The D would go on the inside. Actually, here, I'll write it for you. The D would go on the inside, and the 2 goes on the outside. So that's D divided by 2, or the same thing we have written here, D divided by 2. And this also means D divided by 2. And like I said, this is the way that you'll mostly see these type of problems. So you might want to get used to writing it this way. D divided by 2, or D over 2. All right, so we're done with our basic notes right now. The only thing I'm going to do is I want to go over one type of problem for each part that you'll see on your homework when you do get your homework later this week. So one example, I'm going to write it down for you. Actually, let me skip down here a line. So I'm going to be giving you 2 examples. So this first one is going to be, let's see here. Let's use this number here. Change my mind. We're going to use 12 3/4 less than the product of 7 and, actually I'm going to have to go under here, and a number x. So 12 3/4 less than the product of 7 and a number x. So what I'm going to do first, all right, so if you want to, you can go ahead and attempt this one, try and create an algebraic expression using this. So when you're ready, you can push play again. But I want you to, like I said, I want you to attempt this first on your own, and then you'll come back and kind of follow me and make sure we're doing this correctly. So first I want to go through, and I want to circle some of the parts, or underline some of the parts that are important in this problem. So first, we're going to circle 12 3/4, because that is going to have a constant numerical value here. I'm also going to find 7, because that is a number that we want to be able to use here, and a number x, and again, that's going to be our variable. So there's 3 different numbers, or possible numbers. This is a variable, which will be a number, that we're going to be using. Now I want to go through and I want to underline some of the words in here that are telling me what they're going to tell this problem to do. So first I have less than, and that's telling me this is going to be subtraction. Then I see product, and that tells me that's going to be multiplication. So it's going to be of 7 and a number x. So in all reality, we know that this x and the 7 are both going to be related to this product here. And I think we know that this 12 3/4 is going to be related to this subtraction sign. So if I'm going to write this as an algebraic expression, let's read through this again. 12 3/4 less than the product of 7 and a number x. So 7 and a number x would be represented as 7x, because that means 7 times x. And then 12 3/4 less than that, so minus 12 3/4. So all this writing here gets broken down to look like a algebraic expression. Looks like this: 7x minus 12 3/4. All right, we're going to do one more here, and it's not going to look like this. I'm going to ask you to tell me in this algebraic expression how many terms there are. So let's see, this one could look like v over 3 plus 2 times 5. So if you go back to your vocab on the previous page, and we wrote how to identify how many terms there are in this algebraic expression, go ahead and look back at that. Go ahead and then I want you to circle the terms. And when you're ready, you push play again, and we'll see if you did it the same way I did it. All right, so if I'm looking at this, I'm going to go ahead and flip back here real quick, because it tells me for a term is each part of an expression that is separated by a plus or a minus sign. So I'm looking for pluses or minus signs. All right, well, here's a plus sign. No, that's multiplication. That's not plus or minus. So here's a term, and then here is a term. So how many terms are there? There are 2 terms. So again, only separated by a plus or minus sign. All right, guys, we're done with our notes for today. I know there was a lot there. Some of this might be confusing, but tomorrow we'll go ahead and review this. I'll give you some sample problems, and then we'll get started on the next lesson after this. But again, this is going to be one of the more confusing parts right now, being able to transfer this into an actual written algebraic expression. But again, as long as we keep working this, I think you'll do just fine. So if you guys have questions or anything, you guys know how to get a hold of me. But if not, I will just talk to you guys later. See you.